In the last video, we looked at how electrolytes help with fluid maintenance and regulation. In this particular video, we will be looking at how electrolytes also aid in bone health. There are many micronutrients that help with maintaining our bones. However, in this particular video, we're only going to be looking at the micronutrients that are also electrolytes. We'll also briefly take a look at vitamin D and its function in bone health as well. As a reminder, electrolytes are substances that, when dissolved in water, which water is a solvent, it dissociates into charged ions. Those charged ions being either cations, which are positively charged ions, or anions, which are negatively charged ions. The ones that are bolded here, the micronutrients, these are going to be the ones that we will be taking a look at in today's video. First, we will discuss calcium. Calcium, like the other electrolytes, it doesn't just have one function. Its primary function is going to be for bone formation, and that's what we most commonly associate calcium with. However, calcium is also important when it comes to things such as communication between nerve cells, moving our muscles, so muscle contraction, and also with blood clotting. Calcium salts in our body, over time, they crystallize when our bones are first being formed. They crystallize into hydroxyapatite. This hydroxyapatite makes up 65% of our total bone tissue. So we can say among these three electrolytes that calcium makes up the most of our bone mineral density. Now, bone mineral density, this is saying that the greater percentage of mineralized bone tissue that we have, the higher the bone mineral density is going to be. As we can see here from this image, bone mineral density increases as we mature. Around the age of 30, 35, this is when we reach our peak bone mass. So this is when we achieve the greatest bone mass. And then with time, bone mass slowly starts to decrease. We can see that bone loss decreases more steeply during menopause as opposed to men, where the bone mass decreases more slowly over time. There are several ways that calcium is regulated in our bodies. Again, calcium is primarily stored in our bones. However, calcium is also needed throughout our bodies for other processes. How calcium is able to be used is that something called parathyroid hormone sends a signal to our bones that the bones need to release stored calcium in order to increase circulating blood calcium. By having that calcium in the blood's able to transport it to those areas where the calcium is needed, whether for a muscle contraction, whether for a nerve transmission, etc. The parathyroid hormone also communicates to the kidneys to reabsorb calcium so that it doesn't become excreted in the urine. We took a brief look at the kidneys in the previous video, and we discussed how the kidneys are the body's filtration system. So we want to make sure that any calcium that's in the kidneys, it doesn't end up traveling along our urinary system. We want to be able to take that calcium from the kidneys and be able to still use it in our body. In other words, we want to recycle that calcium. Parathyroid also converts vitamin D to calcitrol. This is performed by the enzyme 1A hydroxylase in the kidneys, which also helps the body absorb calcium from the intestines. Vitamin D and parathyroid hormone act off of each other. So not only does parathyroid activate vitamin D to convert into calcitrol, but vitamin D also regulates PTH, or parathyroid hormone secretion. So in other words, they both work together to make sure that they're both doing their adequate, appropriate job when it comes to calcium regulation. Next, we have phosphorus. Phosphorus builds bones in conjunction with calcium. Parathyroid hormone also works on phosphorus, but it communicates to the kidneys to excrete it rather than absorb it. As we just saw with parathyroid hormone and calcium, we're trying to make sure that we reabsorb the calcium so that we're able to use it. However, we don't want too much phosphorus, and that's why the body sends the signal, the parathyroid hormone, to actually excrete the extra phosphorus. That's why with renal diseases, we need to limit the amount of phosphorus intake in order to prevent toxicities. Because if there's too much phosphorus and if we're having issues with our kidneys, the kidneys aren't going to do an appropriate job filtering that phosphorus, and we're going to build up phosphorus in our bodies over time. Finally, we have magnesium. Magnesium has multiple different functions. Again, bone formation being one of them. However, compared to the other two that we just looked at, calcium and phosphorus, magnesium makes up the least amount of our bone structure. However, it still is an important electrolyte, micronutrient, because of the other functions that it serves as far as our nerve transmission, synthesis of different macronutrients, DNA, RNA. Magnesium has important roles in the body. Next, we'll take a look at the DRIs and the dietary sources of these three micronutrients. For calcium, the DRIs, we have a RDA established for this. Calcium is measured in milligrams. We can see here that needs for younger adults are less than older adults, just because over time we do lose calcium in our bodies. So that's why we need to make sure that we're getting enough calcium in our diets. Now, it's interesting, there is a debate as far as whether or not these DRIs are appropriate. They've taken a look at some countries such as India and China that don't have as much calcium in their diet. They don't have as much dairy products, for instance, in their regular diets. However, in those countries, although they don't consume as much calcium, they also have lower figures as far as things such as osteoporosis, bone fractures, etc. So that's why there is some debate when it comes to whether or not this is actually necessary in these large amounts or not. Calcium is in a lot of different food sources. We typically associate it with dairy. However, as we can see, there's also many plant-based sources that contain calcium. Some products, these ones that say fortified, which we'll talk about what fortified means in another video, but some of these products have calcium added to them in order to ensure that people are getting enough calcium in their diets. These are the DRI figures for phosphorus. Again, we also have an upper intake level established for this one. We don't want too much phosphorus in our diets. With dietary phosphorus, the ones that come from animal-based sources, these are going to be more bioavailable, as opposed to the ones that come from plant-based sources. These are not going to be as bioavailable. Phosphorus is also found in some interesting sources you wouldn't think of, such as cola and cake mix. And that's why when it comes to renal diseases, we make sure that people aren't consuming cola, they're eating lower amounts of meat, just because we don't want to cause phosphorus toxicity. And then finally, we have magnesium. So again, here are the figures for the DRIs for magnesium. We have an RDA established for this one, and we have an upper intake level established as well. And then these are the dietary sources of magnesium. Not as many sources have magnesium compared to phosphorus and calcium. However, we are still able to get magnesium from a variety of foods. So, in other words, if you're eating a well balanced diet, more than likely you are going to be able to achieve all of these electrolyte needs.